students. Today we'll discuss about VLSM part of your assignment mini project. So question is almost similar, but the numbers are different. Okay, but if you know this calculation, you can do the same in your assignment. Okay, so requirements: subnet the 192.168.10.0/24 network using variable length subnet mask. Network has the following requirements. Like Sohar LAN requires 25 host and 25 IP address. Salala LAN requires 14 host and 14 IP address. WAN wide area network and between routers, no, we need 2 host, 2 IP address. Okay, so subnet 1, subnet 2, subnet 3. Before that, Mr. What is subnetting or what is network? What is host? Okay, so see, we have the network 192.168.10.0/24 and this is IPv4 address. Okay, so because IPv4 means 32 bits, we'll discuss the same in chapter 8, but before that just I'm telling. Okay, so just I'll open a new word file. I'll tell you something about IPv4 address. Okay, 192.168.10. This is one address we are given. Okay, the address given for you. This is a network address. Okay, so here this is the address. Okay, this is the prefix. And here each have 4 parts, right? Each one is an octet, any 8 bits. So here first octet, this one, say O1. Second octet means 8 bits. Okay, O2. Third octet, O3. Fourth octet, O4. Okay, so 8 bits. So here we have a octet means 8 bit. Okay, octet means 8 bits. So 8 plus 8 plus 8 plus 8 equal to 32 bits. So this is IPv4 address, which is 32 bits in length. How 32? Because this one is 8 bit, this is 8 bit, this is 8 bit, this is 8 bit. So what we do, we usually used to convert this. No, this is actually decimal. Actually the binary numbers, 192 will be converted to binary 0 1 0 1 0 like that. Okay, so there are 32 bits and we call IPv4 address as 32 bits. It has 2 parts. Network part, the IP address has 2 parts, network part and host part. Okay, so network part means common for all the computers in the network. Okay, host part will be different for each computer. And in every network, the first address will be network address. Okay, say in this case, this is a network address. Okay, and the IP address will be from 192.168.10.1 is the first IP. 192.168.10.2 is the second IP. 192.168.10.3 is the third IP. Like that, the last IP 192.168.10.254 and the broadcast IP. Broadcast means to send a packet to all the computers in the network. We have to use a single IP, that is 192.168.10.255. Because how you got this 1, 2, 3 like that? So here no, from 0, after 0 what will happen? 0 0 0 0 1, then 0 0 1 0, right? Like that. First will be 0 1 2 3 4 5 6 7 8 0. Okay, this is a network part. Then we'll get 0 0 0 0 0 0 0. Last one 1. So it is 1. Like that. Finally, all the 8 bits will become 1. This will be the broadcast address, which we cannot use for any computer. This is used for sending data to or packet to all the computers. Okay, and the last address will be 1 2 3 4 5 6 7. This one, any 2 5 4. Okay, now network prefix. Okay, next is network prefix, means how many bits are given for network. Okay, so here In this we have different type of classes in IPv4 address. Okay, so class A, class B, class C, there are different classes. Okay, so class A, class B, class C, class D, class E. We'll discuss this in chapter 8. Okay, but just I'm telling, class A means the network will have, say, maybe I will take a picture for that one, so that's easy. Let me take one picture. IPv4 classes. Okay, that's one. See, maybe I'll put a picture here. Okay, I'll take an image. This one. Okay, for network. This is good. This one is good. Okay, actually, okay. See here, class A means out of the 32 bits, network will be first 8 bit, remaining 24 bits are host. 888. Class B means first 16 bits, 8 plus 8 will be network, last 2 will be 16 will be host. Class C will be first 3 octets, yani 8 plus 8 plus 8, 24 bits network, 8 bit host. Okay, see, 24 bits are network, 8 plus 8 plus 8, remaining 8 bit for host. That's why here we have 192.168.10.0/24, yani 24 bits are network, remaining 8 bits are host. Okay, now one more thing, in class A, okay, class A or class C, the first octet, see the first octet, and the first 8 bit part start with 192.0.0.2.223.255. This one, see, if the first octet is starting with 192, so this one, sorry, private, okay, not the, don't go for public, just private. Okay, so here class C, the private address, see here, the first octet 192, second is 168, and the last octet, so add 2 from 192.160.0 to 192.168.255.255. If the IP address is in this range, this is called as class C. Okay, see, class C, public is different. Public means we use this for internet purpose. Okay, public network, but private means the one we can use in the local network. Okay, so here see the class C private address, the first and second octet. Okay, octet 192.168.0.0 to 192.168.255. This is class C. See here, subnet mask is 255.255.255.0. Okay, how do you get the subnet mask? I'll tell you. So class C starting value should be 192.168.0.0. Okay, so see here, again this is class C because first 2 octets are 192.168. Okay, now what is subnet mask? Subnet mask means number of network bits. So here I told you 24 bits are network, right? 24 are network. So what I will do, I will write network. See, network equal to 24 bits, host equal to 8 bits. Okay, how do we calculate the subnet mask? Network means give 1 bit value. Okay, 1 as a value. Host means put 0. So what happens? We have 24 bit network. So 1 2 3 4 5 6 7 8, first octet done. Then second one 1 2 3 4 5 6 7 8, again network 1 2 3 4 5 6 7 8. See, 24 bits network, 8 dot, again 8 network bits, again 8 network bits, yani ones. Host means 0, so 8 bits are host. So here we'll put 1 2 3 4 5 6 7 8. Now 8 ones. What is the conversion of binary to decimal? 8 1 means the decimal value is 255. Again 8 1, the binary to decimal. We already done the conversion, or we'll discuss in later. Okay, so how do we convert this 8 1 to 25? This is binary. I want to convert this into decimal. So 8 1 means decimal is 255. Again 8 1 255. 8 0 means 1 0. This is the subnet mask for class C. Okay, you know subnet mask. What is subnet mask? What is prefix? Prefix. Now again, network prefix equal to number of network bits. Yani number of ones. So here, how many ones are here? 8 plus 8, 16 plus 8, 24. That's why network prefix for class C slash 24. You understand? This is a network address. It is class C because the first two part 192, 168 first two octets. Okay. 24 is the network prefix. Yani we have 24 bits for network. Class C means we have the theory. What is the theory for class C? It is network. First three octets network, last octet host. So 24-bit network. That's why we have 24 here. 24 here. Okay. And total 32 bits. So remaining 8 bit will be host. Okay. Network is 24-bit. Host will be 8-bit. How do we calculate subnet mask? How many ones are there? Put the ones here. 1, 1, 1. Okay, 24 ones. So convert this into decimal. We'll get 255, 255, 255. Now, Mr. How do you convert 111 into 255? You know that. We'll just put a table here. Okay. I'll put here. Say 1. All ones, right? 3, 4, 5, 6, 7, 8. So what I have is the position of this one. Okay, it is 2 raised to 0, 2 power 0, yani 1. Next is 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32, 2 power 6, 64, 2 power 7, 128. Now what you will do, you have to multiply these positions 1 into 1. Okay, you know that 1 into 1 is 1 plus, we'll start from here. Okay, 128 into 1, 128 plus 64 into 1, 64 plus 32 into 1, 32 plus 16 into 1. If it is 0 means you have to put 0 there, right? Here all are 1 means you are putting the same number. Okay, understand, Mr. Itza? 8 into 1, 8 plus 4 into 1, 4 plus 2 into 1, 2 plus 1 into 1, 1 equal to 255. That's how we got 8, 1 means 255. Okay, this is the basic. So this is a network address and this is called as class C because we have 24-bit network. Then we have starting octets 192, 168. Then 24 network, remaining 8 bits are host because total 32 is the length of the network. Sorry, IPv4 address. 32 is the total length. Network is 24 means network is 24. Then host part will be 8 because 32 minus 24 equal to 8. Okay. So the host part network is this one. Always the first address is network. Then remaining will be IP address or host address. Can give to the computer 10.1, 10.2, 10.3 like that. Okay. And the network prefix means number of network bits. That is slash 24. And subnet mask, you know, for class C 24 bits are network. So network means put 1. So 81, 81, 81. Convert this one, we'll get 255, 250. Okay. Now we go for the exact question. So see the network given is 192.168.10.0. As I told you, this is class C 24-bit network, 8-bit host. Now what is subnetting? Subnetting means, see, maybe I have a department where 3 different sections. See, networking section, IT section, math section. What I need this network so that I will give different subnetwork for each section. Okay, so I don't want to give all the 255 254 IP address to the network or the department. What I will do, I'll divide this network into three different small network, and they require only say 25 IP address, 14 IP address, 2 IP address, like that. That is subnetting. Subnetting means divide the network into many smaller networks, and each network will require smaller number of IP address. Okay, so that is subnetting. Now there are two different type of subnetting: fixed subnetting and variable subnetting. Okay, so see here, subnetting means divide the network into many subnets, and here borrow more bits for network from host. Okay, so in subnetting what we do, initially we have 24, see 192.168.10/24, network is 24, host is 8. Okay, so subnetting means divide the network into many smaller network, and one more thing, get more bits for network from host. Here we have 24 already, I need 25, 26, 27, like I will take more network bits from the host bit. Okay, and there are two types of subnetting: fixed and variable. Fixed means when you divide a network into smaller networks, all these networks will have same number of host address or same subnet mask. Okay. Variable and subnet mask means every new network, new subnet will have different number of IP address or host address and different subnet mask also. Example here, see, when I divide the, I will take one other this one. Okay, this one. Okay, see, I am going to divide this network into three different network. See, each network requires different number of host address. One require 25 host or 25 IP address, another one require 14 host address, another one require only 2 host address. So different number of host or IP address they need. This is called as VLSM, variable and subnet mask. Okay, and they will have different subnet masks. I will tell you later. Okay, so variable and subnet mask means when I divide a network into 3 or 4, whatever you are dividing, each smaller or subnetwork require different number of IP address. He is, in this case here, see, Soharland requires 25 IP address, Salala requires only 14, and WAN requires only 2 host address. But when I go for fixed subnetting, this is variable and the subnet mask. Okay, and here the subnet mask also will be different, or prefix will be different. So here when I go for this one, okay, that will discuss later. Okay, so fixed subnetting means it's not like that. I divide the network into maybe 3 different networks. Each one requires same number of IP address. One requires 30, other also require 30. Third one also require 30. This is fixed and this one is VLSM. Okay, so fixed subnetting, you have your this one activity in your lab manual. Practical activities, let me check your question. 11.5. Okay, this one, let me check this one. Customize packet tracer. See in your question paper, okay, let me check your acting e-learning. See, already people have started submitting assignments. Okay, Omar finished, then Yakin finished, then yesterday first one to finish was Miss Daya. Okay, all of you finished that not assignment, actually that outclass activity 3. Okay, so here when I go to the lab manual leave learning, I could see that where is that, this one 7.11.5.5. okay, so I will take this question, subnet a network. Here is fixed subnetting. Okay, this is fixed subnetting. Okay, so every computer requires, or every subnet requires same number of IP address. Okay, leave it. Okay, that is fixed subnetting, variable subnetting. Now you need to fill this table. Actually I filled the table because when I am making the video I will not get time for filling, so I fill the table, then I will show you how I fill the table. Okay, so remember this one, this is 192.168.10.0/24. This is class C, 24-bit network, 8 for host, and we are going to subnet this into 3 different subnet. Each one has different number of host address. Subnet mask will be different. That is VLSM, variable and subnet mask. Okay, now So given network, we are going to start the calculation. Network is 192.168.10. This is class C, Mr. Omar, and it has class 24 bits network. Okay, so network will be 24 bits, host will be 8 bits. Okay, now subnetting means divide a network into many subnets. So borrow more bits for network from host. So during subnetting, 24 will change 25, 26, 27, and this one will change, reduce to 6, 7, 5, 4 like that. Okay, so fixed subnetting and variable subnetting written here. We are going for the VLSM, variable and subnet mask. So Soharlan requires 25 IP address, subnet 1. Salala requires 14 host or 14 IP address, subnet 2. WAN requires 2 host or 2 IP address, subnet 3. Okay. Start with the maximum host requirements. Okay. So here who needs the maximum? Soharlan. How many? 25 IP address. Okay. So Soharlan requires 25 host or 25 IP address. So we are going to start this. Okay. So 192.168.10. So as I told you, subnetting means take more bits for network from the host. Okay. So what I will do, I am not touching the network part. Network part is first 3 octet, right? 24. So 8, 8, 8. This part I am not touching. I am taking the last part, any host part. So take 8 bits. Take the 8 bit, any host. Okay. And now there are some formula. So the formula is number of hosts required. How many hosts we require? 25. So what the formula is, H means we'll put host, okay? N means network, okay? So 2 power H minus 2. This is the formula, okay? 2 power H minus 2 equal to how many we need? 25. So what value of H will give me 25 IP address. So if I go for 2 power 1, 2 minus 2 will be 0. If I go for 2, 2 power 2, 4 minus 2, 2. Yes or no? If I go for 2 power 3, 2 power 3, 8 minus 2 will be 6 only. If I go for 2 power 4, 16 minus 2 only 14. But if I take H equal to 5, 2 power 5 means 32 minus 2. I will get 30 address which is greater than 25. I cannot get exactly 25. I'll go for the nearest value. So 2 power 6 is more. 64 minus 2, 62. Don't waste it. So better 2 power 5 minus 2. And 2 power 5 is 32 minus 2, 30. This is the best one. Almost near to 25. So I need 25, but I can give only 30, nearest one. So which value of H give you that much host address? 5. That means I need 5 host bits. I don't want 8 host bits. I want only 5. So take the leftmost. See 1, 2, 3, 4, 5. I take only this 5 bits for host. Okay. So 5 means 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16. I take only the first 5 bits. Okay. What about the remaining 3 bits? Mr. How you take 5 bits? Because I need how many IP address? How many host address? 25. The formula is 2 power H minus 2 equal 25. So only 2 power 5 will satisfy your requirement. So 2 power 5 minus 2, 32 minus 2, 30. I will take H equal to 5. So out of this 8 host bits, I will take from the left 1, 2, 3, 4, 5. 5 host bits I will take. Remaining 3, who will take, Mr.? As I told you, subnetting means network will take or borrow bits from host. So this 3 will go for network. See, network, network, network. Okay, 3 bits for network. Now I told you, network means put 1, host means put 0, right? Now what is the new network prefix? When I started the calculation, network was /24. Now how many more bits for network? 1, 2, 3. So 24 plus 3, 27 bits for new network prefix. What about the subnet mask? Earlier it was 255, 255, 255, 0. Now what is the new subnet mask? 255, 255, 255, MAFI 0, 224. Because in earlier, all the 8 bits were 0. That's why we put 0 here. Now we have 3 bits 1 in network and we got 224. How we got 224? See here, multiply the new network bits into its corresponding decimal number of that position. See, now we have 3 new network bits, right? 128 into 1. 128 plus 64 into 1, 64 plus 32 into 1, 32. Remaining all zeros. You don't need to add. When you add these three, you will get 224. That's why 255, 255, 255, 224. Mr. Why this is not changing? Because Mr. We have network bits 24. That is not changing. Host bits we have 8 zeros. In that 8 zero, I take only 5 host bits. Remaining 3 will go for network. So 3 more new 1. So when I calculate the new subnet mask, these things we have to add. That's why we got 2 to 4. Okay. Now how many new subnets we can create here? Okay, I'm going to divide the network, right? So when I divide the network, how many new subnets created? Depends upon the formula 2 power Sn. Yani how many subnet bits you borrowed. So here I borrowed 3 bits, right? 3 bits from the host. Out of the 8-bit host, I took 3 for the network. So 2 power 3. 2 power Sn means 2 power how many bits you borrow for the network. So 2 power 3 equal to 8. Yani 8 new subnets we can create. Okay. Now what are the new subnets? First one will be the same question. What is the question? 192.168.10.0/27. Okay, so we have one second subnet, third subnet, fourth subnet, fifth, sixth, 7, 8 because we have 2 power 3, 8 subnets. Okay, what is the next network? Next network is 192.168.10.32, which is how you got 10.32/27. 27 is our new subnet prefix. Okay, early 24, now 3 more bits for network, so 27. First, I understood, Mr. 192.168.10.0 from where I started, same thing. How you got this 32? 192.168.10.32. How I got is, see a easy method. What is the last bit of network? See, this is network bit first one, 128. Second one, 64. Last network bit is position 32. So, differ, each networks differ by 32. So, next one will be 32. What is the next one? 32 plus 32, 64. Again, 64 plus 32, 96. Again, 128, 160, 192, 224. Okay. This is new subnets. Understand? As per the requirements, Soharland requires 25 hosts. So what I will do, I will take this first network. I'll take the first one. And what is the first IP? This is the network part. Okay. So we already discussed every subnet will have 30 host address. How, Mr.? Because we have a formula here, no? 2 power 5 h minus 2 equal to 32 minus 2, 30. So we have 30 IP address in every network. Okay, new network. So here, this is our network I take for Sohar. So first address will be 192.168.10.1. Second is 2. Last one is 30. Because I have 30 IP address, Baba. And broadcast is 192.168.10.31. I cannot use this for any computer because this is for sending a message to all the computers. Okay. And again, also one method, another method is, see, first network is 192.168.10.0. Second network is 192.168.10.32. So we cannot go beyond 31. So 32 is the next network. 31 is broadcast. Last IP is 30. Okay. First IP 1, second IP 2. Last is 30 because 32 is a network, 31 is a broadcast. Or we can say every network has, in this case, 30 IP address. So we can have 1 to 30. Don't take 10.0 because this is network part. Okay. This is done. So based on that, we have to fill the table also. See here. Subnet 1 IP to Sohar LAN. First IP address to host address to G0 bar 0 of Sohar router. So G0 bar of Sohar router means 192.168.10.1. Mask is 255.250.224. You know that. Then second host address to Sohar admin PC and its gateway. Sohar admin PC. So this is 1 means Sohar admin PC will be 10.2. Mask is same. What about the gateway? Gateway means the router's address. Okay. Sohar admin PC connected to Utah Sohar router G0 bar 0. That address is 10.1. That will be added in gateway part. Yes. Okay. Then Sohar guest will be third. So dot 3. Then Web server is fourth address 10.4. Sohar switch is last address, so 10.30. Understand? Now return here. From here, based on this, you have to fill the table. Now we go for next LANs, Salala LAN 14 hosted. See, they need only 14. So what is the formula? Number of hosts is 14. Yani 2 power h minus 2 equal to 14. That means I need only 4 host bits because 2 power 5 is 32. I will have 30. No need. I want only 14. So 2 power 4 will give you 4 minus 2 power 4 16 minus 2 14 host address. Okay. So 14 means I need only 4 host bits. So what I will do? I will take only 4. 1, 2, 3, 4. Okay. We have 5 already. Out of that I want only 4. So what about the 5th bit? Who will take this 5th bit? See, remember in the earlier case I had 5 host bits, 3 network bits. Now I need only 4 because 2 power 4 is my requirement, 14. So this bit, where is that? Is going to be extra, right? I want only 1, 2, 3 and 4. This, what happens to this one? Old will change to new. What happened? This will be borrowed by again network. Network will borrow it. Okay, Baba? Now, what is the new network bits borrowed? 2 power, how many we borrowed? 1. So 2 subnets. Okay, we borrowed only 1 now, right? Remaining 3 already borrowed. Now we borrowed only 1. So new subnet is 2 power 1, 2 subnets. Okay. What about the prefix? It was 24 in the beginning. After first subnetting for Sohar, we took 3 more. 24 plus 3, 27. Now we have 1 more, right? So prefix will become 25, 26, 27, 28. See, 28. 27 plus 1. New borrowed mask, network bit is 1. What about the new subnet mask? Add 128 into 1 plus 164 into 1 plus 32 into 1 plus 16 into 1. So total, when you add all these things, you will get 255, 255. This is not changing because network part is in the beginning, it is not changed. The last octet is only changing. Okay. So last part is 240. Okay. We add all these 4. New subnets. What are the new subnets? First thing we have to start from. Where we started? We started from subnet 2. Yani 1 is already given for Sohar. After that we take second one for Salala. Dot 32. Okay. So that was a starting point. From there I need 2 subnet. Okay. So how do the subnets differ? See, last bit of network is 16. So first one will be 192.168.32/28. Okay, now it is 28. Okay, 27 plus 1. Next will be this 32 plus 16, 48. Clear? New subnets are 32/28 and 48 because last network bit is 1. Sorry, last one or network bit is 16 corresponding one. 16. Okay, so add this part by 16. 32 plus 16, 48 is next network. So Salala network requires take this network and IP address will be again how many IP addresses are there in each subnet. In this case we have 14. Yani if I take 32 as a network, IP address will be first one 33, 34, 35 up to 46. One reason is 32 is a network, 40 is the number of IP address. So 32 plus 14. It will be 46. Broadcast is 47. Or we can say next network is 192.168.10.48, right? So 47 is the broadcast. 1 less than that. 46 is the last IP. First IP, last IP. Okay, it's written here. Now how do we fill the table? So Salala LAN has 32 network, first 33 IP address, 34 second, like that. Mask is 255, 255, 255, 240. Okay. So see here, go to this table here again. First host address to see subnet 2, any 192.168.10.32/28. Okay. First host address is G0/0 of Salala router. Second to Salala admin BC, third to Salala guest, fourth to FTP server, last Salala switch. Okay. So Salala router 0/0 192.168.10.33 240. Server admin PC second one 33 by 34. Mask is same. Gateway is this Salala admin PC and all connected to Salala router G0 bar 0. So this IP address will be the gateway. 33 will be gateway. Salala guest means third. So 33, 34, 35. FTP server fourth, 36. Salala switch will be last IP, and 46, because 47 is the broadcast address. Okay. Clear? Now last part, WAN requires 2 hosts. Okay. So what we will take is, after we took which one? This one for Salala. Now this is remaining 48. I will take this one now because we don't want to waste any network or IP. So we'll take this one now. Okay. I'll take this one. Now what is the requirement? 2 host or 2 IP address. So here network is 28 bits. Okay. Host is 4 bits. Now we require 2 IP address or 2 host address. Okay. So number of hosts equal to 2 power h minus 2 equal to 2. So 2 power 1 is 2 minus 2, 0. Not possible. So to take h equal to 2. 2 power 2, 4. 4 minus 2, 2. This is the best one. So I need 2 host address. 2 host bits. Okay. I already have 4 host bits with me. I want only 2. I will take these 2. The remaining 2 will go for network. Clear? I have already 4. In the previous step, I took 2 power 4, 16, right? Here I want only 2 host bits because I had only 2 IP address requirements. So 2 host address I need. So I will take the first leftmost 2 bit. Remaining 2 will go for network. This will go for network. So what I will do? This 0, 0 will become 1, 1 because network is 1, host is 0. Now, how many new network bits, new subnets we have based on the number of network bits we borrow? How many we borrow now? 2. So 2 power 2, 4 subnets created. What about the new network prefix? Network prefix means how many network bits are there? See, 1, 25, 20, already 24, no? 25, 26, 27, 28, 29, 30. Now the network bits we borrow, total becomes 30. That is network prefix is 30. What about the new subnet mask? 128 into 1 plus 64 into 1 plus 32 into 1 plus 16 into 1 plus 8 into 1 plus 4 into 1. Add all these things, you will get 255, 255, 255, 252. Okay. What about the new networks? You remember what is the last position of n? It is 4. So start with the question. What was the question? We started with 192, 168, 10.40. That is the first network. Okay. Slash 30 will be the first one. Okay. Because we have network bits now 30. Second will be add by 4 because last one will be 4. So 52. Next is 60. Next is 64. Okay. Now we take the first one for the, which one? WAN. We take this one. Okay. What is the first IP? 49. 48. But we have how many? Only 2 IP address. So 48 is network means 49 is first IP. 50 is second IP. Okay. 51 will be broadcast. 52 is going for network. Okay. So we cannot take 52. 15 also we cannot take because broadcast. So what we have is 49 and 50. This 49 will give for, as mentioned here, first host address to serial 10 Sohar router will give Sohar router 192.168.10.49. This is the subnet mask. Second one will be Salala router 010 192.168.10.50. This is subnet mask. This is how we do the IP addressing part in your mini project. That's all. Okay, go through this video carefully. You will understand.